Alright, so the plan for today is to create something like HTTP server, but entirely from scratch in C. So if you don't know HTTP server, how it works, let's just create this HTTP server C. And if I run the Python 3 thingy, http.server, I guess I have to use -m, right? It starts an HTTP server on port 8000, like localhost. So you can just do localhost 8000 and you see all the files inside of here. So if I, let's say, touch, or I guess we can also write something in it. So we can do like index.html, I guess. So, and like hello world, right? If I just write hello world inside of it, it's gonna give us hello world. And if I, for instance, rename this thing into something else like hello, okay, and I refresh the page, we can see the page here. And if you go to it, it renders the content, but rendering the content is on the browser, not on us, right? So yeah, it's mainly file-based routing, right? And it yeah, I guess the browser also shows this stuff, right? So hopefully, I don't know, but the goal would be to just put something in the path, like hello slash something else, and our C app would parse this path and render the file here. And I guess if it doesn't exist, probably something like this. So yeah, and I think this could be interesting because we'll see how HTTP works, so like the protocol itself, and basically how stuff like Express.js and Fast API and all of that works. Yeah, so but I mean the first part, creating the sockets and all of that, is pretty simple. I think we've done that before, and yeah, we never looked into how HTTP works though. So yeah, basically imagine we have an like a app that uses sockets like the C ones, and we just do a curl, right? So let's just try that, right? Let's remove this file and then let's create main.c here, and as usual let's include std_lib.h and then have int main printf hello world. So yeah. Or I guess it's stdio. Okay, whatever, I already forgot. And then if we run main, we get the hello world, right? So I'm just curious if we are gonna find not really, because yeah, what we need to do, interesting, it said that there is no man page, but something like this, anyway, doesn't matter, because yeah, that's what we want to use, the sockets from like sys socket. So I just wanted to see which header I need to include, but yeah, so we need to include sys socket, and then we can use this function. Let's just paste it here. Right, so we want all of these things. Maybe we have an example. Yeah, because the man page is pretty much the best one. So here we have some things. It also has like return codes, but let's not look into the errors right now. I think that errors anyone can. So I'm pretty sure the first argument should be AF inet, right? Without the 6, like this one. So this is the domain, which I guess is the protocol that will be used, right? So in our case, it's gonna be IPv4, right? Something like that. And then probably sock stream, right? Like this would be yeah. Oh, the LSP doesn't work. Interesting. And lastly, it's the protocol. So also non-block, whatever. Interesting. I didn't see that. So if I search for this word, okay. So we should pass a 0 in the protocol. And here it says that the protocol strange. Damn, it's so overcomplicated, but whatever. I think, yeah, whatever. So we have like the result, and then result is equal to this thing, and then if result, I guess it should also say that. So on error, -1 is returned, right? So if this thing is equal to -1, then basically we are kind of cooked, right? So see the error. I think p error is nicer to use than all of that. So you can just say something like p error socket, and it's gonna say this like error was at socket, and I think it also shows you the error now. So that's pretty cool. And the last thing we have to do is just close the thing. So let's see if wait, p error, it's in stdio. Pretty cool, not gonna lie. If we run this thing, well, we got to this point, so we got the socket back. But well, I guess for the socket we could just say fd, right? Just to have it. So yeah, basically this socket function is the same thing as the open function, right? It creates a file descriptor, and if you write that file descriptor, you kind of assume that you are gonna send those things on the network, and if you read from that file, you assume that you are gonna read something that came from the network. And I guess it's the job of the drivers and like hardware stuff to actually fill that file when you read it, and flash it on the network when you write to it. So it's like a pretty cool way of just um, having a file, and you just read and write to it, and the operating system does the rest, like handles the networking. But we still have to bind this file descriptor, and that's why I would rename it into fd. It's a file descriptor. And yeah, we have to bind it to like an actual address and port, right? So we have to use the bind function. So, and I guess this one can use the result. But yeah, it's pretty strange. Well, now it works. That's weird. Okay, so see here in this description, it tells us that if protocol is 01 is chosen automatically. So it creates like a sock stream socket in IP4, and I guess you can put multiple domains, and if you put 0 here, it chooses one, like protocol. But yeah, whatever. Doesn't we don't care about that. As long as it works, right? That's pretty much the idea. So yeah, as I said, we need to bind this FD socket. But as you can see, we need some sock address and len, which looks pretty strange, but we can handle that. So we pass in the socket file descriptor and we check the result. Right, so here we need something and then something else, but we don't know exactly what those things are. So let's just check the manual first. Really? Oh, this is for the fish shell. I don't know how to search the manual for bind. That's so weird. So yeah, we need this sock address and sock len t. Right, so sock address is pretty simple. I think everything is inside of socket, so that's pretty neat. We already have it. So yeah, this is like a structure. I don't remember exactly if we had to implement this one when I did the networking in cool language, which was like the language that we implemented, the compiler, and we had networking inside. So yeah, I think we had to add sockadder into it. Oh shit, this is what we have to implement. See, like, it's always nice to search the manual because it has examples, and I guess, oh, I didn't read the full sentence, but yeah, so it says it shows an example here, and I guess it's like the entire code, right? Okay, anyway, so yeah, I just wanted to see an example of using bind, right? So yeah, we would have anyway, because yeah, we need to use sock len from there and sock address, and here it's usually in because it's this is for Unix. I don't know the difference, but I know it's different structures for each protocol, kind of. So yeah, let's define that. So sock in, and then we have like the address, right? Well, can I search for... At least I can see this thing. So what I'm interested in is this sock address in thingy, right? Oh, so I need this include. Okay, pretty easy. And yeah, this thing has a few fields, and if you remember from this one, this structure is kind of like it has the family and then it has like some data, 14 bytes of data. And here I think that structure is split into, again, the type or something, and then we have a few bytes for the port and a few bytes for the address. And I think in total it doesn't have to add up to 14, but it has to be under 14. Like, I think this uses 4 bytes, or I guess 2 bytes, because it's the port. The port can fit in 2 bytes, if I remember correctly. And then for the address, 4 bytes or something. So in total it's like 6 bytes, but we have a few to spare. At least that's how I remember I implemented it when I did it in my own language. So yeah, pretty cool. So yeah, we just have to fill in these fields now. So let's see how they did it in the example from here. So yeah, we just have to set the family, so scene family, something like address.scene family. And yeah, I mean, I never understood why you have to say this one here, also here, but whatever. So scene port, and here we can put 8000, but I'm planning to take the port number from, let's say, the argv. So you can actually specify that. And the scene address has more stuff to it, so it's like SADDR. And I just have to remember how you specify like 000 basically, so like everything. So the in address has this SADDR, right? And then there's this stuff. It's a uint, but I'm pretty sure you had to specify something like all addresses. So I mean, this one doesn't have get address info, doesn't have what I wanted. And bind has an example only for Unix sockets, which, like, sure, Unix sockets pretty cool, but they are used, I think, only for process, like inter-process communication. And the ones that we use, if inet, they work also over the network, so there's a difference. But yeah, that's what I just maybe the listen man page has an example. Oh, maybe accept, because accept is clearly not really, that's sad. Connect, like connect obviously does. No. So what can I search for? Like sin sock address in example. Sock address in example. I guess, you know, the easy answer. Oh, that's interesting. You also have to do host to network, right? That's a pretty good one. I didn't think of that, right? So usually the networking stuff has like little endianness instead of, or I guess big endian instead of little endian. So you just have to do host to network. And then this one's interesting. inet p2n. I don't know what p2n means, but sure. Let's see if I have this function actually. Oh, not really. So this one is in ARPA inet. Let's see what it does. Maybe it's an easy way of populating that stuff, right? So oh, interesting. So, you know, all of that stuff. So we use the domain, so f inet pretty much. This is our domain. Then arg2. So that's like 000, right? The address. Yeah. Pretty weird. Don't really remember. Something like that. So as a third argument, I would say it's actually the sock address itself, right? That's how it should be. So here it does buffer. Huh. But yeah, like scene address is what I would put here, and that's on address. And yeah, obviously like that. Okay. So scene address was the third thing here. Like internet address, yeah. Okay, fair enough. And see, like here it pads with zeros, so it's like not full, right? So address in. Anyway, so now we can bind this thing, hopefully. And we want the file descriptor that we just created for our socket. We want the address and the address length. I guess, you know, address length because we need to specify the type, but we don't really know how, so yeah. Just curious how we would do that length. Size of. I don't know. So the file descriptor, then we need to pass the address and size of. From what I can see, size of. Oh. size of address. Does it need to be a pointer? Yeah, for some reason. Wait, yeah, it gets a pointer because it's like generic, right, in quotation marks from what I can say. And then we can check the result. If it's equal to -1, we can do the same error handling, right? And here it's bind. So let's try it. It still works, so hopefully, wait, run it again. Yeah, so here we binded that socket to like port 8000, right? So the next step is to, I guess, actually listen. We have the example here, right? And listen just, enables the thing. So we can do like result is equal to listen, and this one takes the file descriptor, so the socket file descriptor, and how many connections do we want to make, I guess, right? So let's do like 10, doesn't matter for now. So prepare to accept connections, right? And n is the request that will be queued. Pretty cool. So it's not necessarily how many requests we do in parallel, it's just how many requests we can put in our queue. And then regarding the how many requests we do in parallel, we have to actually run accept in in a loop and then spawn a new thread and stuff like that. So that's basically the next step. So let's check the result. If it's -1, we just no, but I really like this handle error. Let's use that instead. So here we would do like handle error. I just need to figure out. Okay, listen. Where do we get the from stdlib? Okay. So now we also listen on that file descriptor, right? And next step is to just accept one connection. And I think that's could be pretty cool. So, right, we have the address, and let's also have like client address. Okay. I mean, just copy paste that. And let's just add it like this for now. So, I mean, you can keep it as the example. So yeah, why not? So here it's client address size, client address. Yeah, I mean, I renamed it like that. And this one, okay, fair enough. It's client file descriptor. Then it can make sense to use server file descriptor, right? So if you run accept on that server file descriptor, we get back a client file descriptor, and this client one is basically where we read and write to communicate with the this particular client. At least that's how it works. And here I think we can pass null for both of them if we don't care about it, but it's nice to have this client address because we can find the IP address of the client, and I guess also the port that's used or something. I don't know if you can, like, it doesn't make sense to see the, I guess it's the port from our side or on the server side basically, but yeah, whatever. And then the client address size, right? So yeah, we get this client file descriptor, and if it's -1, obviously there was an error which we can handle. So accept, and that would be all here. Like if we start it, you can see it waits because of accept, and let's just do like a curl, I guess. Well, we can use netcat, but I don't remember the syntax. Okay, yeah, it's the host and the port, and it ran into accept. It accepted the connection, it worked fine, and then it got over to this point. So yeah, that's pretty cool. And I guess the next step is to actually, yeah, I mean, to deal with the incoming connection, and then we have to close the things, right? Probably close is inside of, I mean, UniSTD, it's like syscall or something. But honestly, let's just do it like this. So yeah, here at this point we are gonna do something like send one message, maybe read the message, but yeah, we'll have to see how the, okay, also unlink my sock path. What the fuck? Yeah, I guess, you know, because this was done with Unix sockets. If you remember, we had to do something different here at this one. So here we had to do this inet Python. I yeah, I have no idea what P to N means. Like for the longest time, I had no idea what H to N meant, and it's like host to network. But Python, yeah, I don't know what it means. P to N. Yeah, I mean, probably it's something like P to network, but I don't know what P means. Like string, right? Anyway, so yeah, we can just handle stuff. And yeah, what I was saying is that here it's creating a file for the Unix sockets, and we are creating this, or I guess we are just using 000. So it's like whatever. Anyway, so yeah, let's try to, wait, what? Holy shit, they were one space wrong. Okay, I guess some evil guy, yeah, whatever. So yeah, let's try to maybe just read from the client. like, I guess writing to it, it's gonna be simple, right? So as I said, it's pretty cool that you can just call to write. Say you put the file descriptor, and it doesn't really matter if it's like a socket file descriptor, and right, it's just gonna use it as a file, writes to it, and the networking part of the OS is gonna handle the, sending the data for us. So let's just try to use it. So let's put here the client file descriptor. Hello. Maybe let's also use a new line just in case. And then the size should be 6. Let's hard code it, right? It's like 6 characters, hopefully. So let's start the server and let's try to netcat. So pretty cool. We get the hello message. And yeah, I mean, I'm not sure. Maybe it's because of netcat, right? It stays in the thing. So whatever. Like sure, we could also try to read something and do more stuff, but I think yeah, just that is fine as a first example. And let's see now what would happen actually if we read something. That's actually more interesting. So read works the same. We get the file descriptor, so cfd. Then we need a buffer, and let's create it here, like buffer, and let's say we have 1024 characters available, and probably how much we read, right? Like at the most this quantity of bytes. Can I say it's 0? Probably I can. And then let's just print f percentage s buffer, and we can do something like client and then some quotes around it. Okay, I think that looks fine. So let's start it, and then if we netcat, I think if you do something like this, yeah, it sends the stuff. Okay, nice. But see, like the server stops, doesn't oh, and then we have this weird issue, which I guess it's something to do with not closing everything. And usually what I just do is, okay, let's do another port. Which is sad, but whatever. And let's try to curl localhost 8001, and let's put something like hello. Alright, so this would be, probably it's not gonna work because server is not gonna respond, but we see what kind of message we get. Right, so we get the get, like the verb of the thing, then we get the path, what kind of http it is, then stuff that's not important like headers, so host, user agent, accept, and whatever. So these are the headers. Pretty interesting, right? So if we manage to parse this thing, we can say, okay, let's check the hello directory, right? And let's send the data back to the client. And obviously here it's complaining that it receives something, but it doesn't make sense because we didn't send anything. So that's the idea with the HTTP. We want to try to figure out what we get when we use curl, and then we want to figure out what we have to send. So we kind of reverse engineering the HTTP protocol just to figure out how it works and just try to make the curl command work. So yeah, that's what I think we can try to do. But obviously the first step is to maybe make this thing, well, actually it's more like reading should be done in a while loop. I mean, it depends. If we want to accept multiple connections, we can do that as well. But yeah, we shouldn't stop after reading one message. We should keep the server running. That's the first thing. And yeah, afterwards would be pretty interesting to see how the stuff is gonna work. But yeah, I guess that's all I have for today. It's just like an introduction after the break. And yeah, let's see what we can do in the next videos. It's like, yeah, probably I'll try to do multiple accept connections. I guess that's pretty obvious how to do, but maybe it's not, so let's do it together. And yeah, the while true and then have a read here, that's, I guess, pretty obvious how to do, so I'll do it on my own. But yeah, let's do the multiprocessing stuff together. And yeah, I guess that's all for today. So yeah, and also next time we'll figure out how to parse this thing, and maybe even how to respond to the curl request. That's gonna be interesting. So yeah, thank you for watching and see you next time.